Okay, great stuff. So we're back now and we're going to continue working through some of the examples from this section, which is related to finding the equation of the circle. So it's a pretty big section in, I'd say, all this, the Leaving Cert course, these text and test books, I'd say, out of all the sections that are chunkiest, it's probably this one, because of all the different methods there are to find the equation of a circle. So what it's trying to show you here is there's a flavor of different types of questions that can be asked, and it's trying to give you a demonstration of the different scenarios you could be presented with in an exam. If you want to get really good at the circle questions, it's just a matter of practicing as many of them as you can, and that way you'll see a variety of the different types of scenarios they can put you in. And so this is one of them here. We'll talk through this. I'll set it up here. Um, they give us a diagram. Will I work with their diagram? Sure, let's imagine we didn't have the diagram. So this would probably be what you'd be given in the exam. You wouldn't be given the diagram. So I'll build this up from scratch, showing how we do it, because we have to get good at drawing sketches. Find the equation of a circle which passes through this line, which touches this line at the point 5, 3, right, and which passes through B. So it's very clunky information they've given us there. But they're saying that if this touches the circle, and they're kind of implying it's a tangent, so it could be a bit better worded there, to really imply that it's a tangent. Right, so how would we draw a sketch of this? So we know that A and B are on the circle, but the main thing that I want to get us sketching here is this guy here, so the tangent. So we should know that the slope of that guy is minus what's in front of the x divided by what's in front of the y, so that's minus 3 over minus 4, so that's a slope of 3 over 4, so we know it's a kind of upward sloping line. What we could do then is we could go and get 1 point that it goes through. We can get 2 points if we want to draw a really good sketch of this, so just in case people don't remember how to sketch a straight line like that in a quick way, it's usually best to find like the x and the y intercept. So we can set x to 0 here, so tell the examiner we're doing that. We're setting x equal to 0, so 3 times 0 minus 4y minus 3 equals 0. So then we're getting something like 4y equals minus 3, and then y equals minus 3 over 4. So that's a point on this line, 0, comma, minus 3 over 4. We can get the other intercept by setting y equal to 0. And when y is 0 up here, we go 3x minus 4 bracket 0 minus 3 equals 0. So this isn't part of our solution here. This is just us sketching this line here if we want to do a good diagram of this. And it's no harm doing a good diagram of this. So x equals 1 from that. So the point is 1, 0. So we can mark this in then, so we can say that this here is our 1, 0. And then this here is our 0 minus 3 over 4, something like there. Good to always draw nice big diagrams, you know. So then this is this line here, and this is the line that has the slope as we done there before of 3 over 4. So you'd have this as like some rough working paper. You wouldn't want all that to take up too much of your space, because that's just all of that workings there was just so I could draw a really good accurate diagram of this line as such. And yeah, you want to be able to do that in an exam, is draw good decent lines like that, you know. So we come over 5 and we go up 3, 5, 3 to get this point, say about here. Now this is on at the point 5, 3, so you can see that is pretty much on the line as well too. So we'll put that in there. So it's about 5. That's about 3 there. Mark it down there. Okay, so that's on the circle. And then we're also told at this point minus 2. Where is it here? Minus 2 on the x-axis, so that's about there. Minus 2, and then we come up 4, so maybe about here. So this is a point here. And they call it B, but maybe more important is putting in it as minus 2, 4, stating its coordinates, you know. I should have called this here as well, 5, 3. Right, so if we study this carefully, we're trying to, and you could get your compass and start messing around with this to try and fit a circle that is a tangent to the purple line at the orange point. So let's see, can I do something like this? But then also goes through the red point. So it's not a million miles away there of what we're going for. So yeah, so that's a sketch of that there, circle. So it's a little bit of a big diagram, but what can you do? Okay, right, so what do we want to do here? So actually solving this circle question. So in our diagram here, we can see that, I'll actually bring that down a little bit so we can see it full screen. Try and grab that circle as well. Yeah, I'll pause this so I can get it down one sec. Great stuff. So that's what we're working with. So to find this equation of the circle, we're going to need the center and radius. And so to get it from this scenario here, so an important thing is, this is going to be the first trick I'm going to show people here, is that we want to get these lines that go through the center of the circle. So this here is 90 degrees to the tangent. So remember we knew that the slope of the tangent here was 3 over 4. So that's great because then we know the slope of this line up here. This is minus 4 over 3 because we flip it and change the sign. Now this is great because look at this. We have that this blue line, which goes through the center of the circle, goes through 5, 3, and we have its slope. So we can create its equation using y minus y1 equals m times x minus x1. So I'll do that here where I label this, x1, y1, and then that's my slope there. So I'm going to sub that in here. I'll pause the video. I'm sure everyone can do this. Okay, so I worked all that out there and I got myself a 4x. That guy there is 4x plus 3y minus 29 equals 0. So to find the center here, I'm just going to need another one of these lines. And think about this. What did I teach everyone in the previous video? It's that if you have 2 points on a circle, let me get a good color to mark them in. We have this point on the circle. So when you're given 2 points on a circle, you need to know that you can construct a perpendicular bisector through them, where you get the midpoint between them here, using the midpoint formula, then you get the slope between them, and then you get the slope of the black line, and you use your y minus y1. So I'll do that because I showed that in a previous video. I'll just build that up. I'll pause the videos here. So I'll find the midpoint first, using the midpoint formula. So I got the midpoint there. It's 3 over 2, 7 over 2. So now I'm going to get the slope of the lower black line here. I'll mark that lower black line in as red. So this isn't the actual slope that I want. What I do want is the slope of the black line. So I'll work out the slope of the red line first by using the slope formula, like between these 2 points, y2 minus y1 over x2 minus x1. So I'll pause. Okay, so I done that there and I got myself minus 1 over 7. And that looks pretty good with the diagram because the red line is very slightly sloping downwards, isn't it? So that's why a good big diagram like this is actually a great idea because my calculations are actually lining up with what's visually going on the screen. And so then the slope of the black line, which is the slope I want, the slope of the perpendicular bisector, I flip this, change the sign, and I get this very aggressive slope of 7. A slope of 7 is like this here, where you're literally rising, for every 1 unit you run, you're rising 7 units. So that hypotenuse there is something that has a slope of 7, and that looks pretty close to what's going on there. So again, our diagram is keeping me sane here. Like I know that my calculations of this working out as 7 is correct. So now that I know the point that this perpendicular bisector goes through, and I know its slope, I can go and work out its equation here by using y minus y1 equals m times x minus x1. So I'll pause the video here. Okay, so I done that. I put that point in and that slope in. So I got 7x minus y minus 7. So just update my diagram with that. 7x minus y minus 7 equals 0. Let's do a sanity check. Let's check the slope of this line. Minus what's in front of the x divided by what's in front of the y. That's minus 7 over minus 1, so the slope matches up. Pretty good there. So now you have 7x minus y minus 7 equals 0 goes through your center, which we're looking for, and you have this line as well goes through your center. So you solve them using simultaneous equations, junior cert kind of problem. So I'll pause the video and do that. Great stuff. So I solved them using a simultaneous equation there, and I got this point. What's a good color to use? I might use blue here. I got 2, 7. Now, sanity check time. Let's check the diagram. Does this look like it's at 2? Well, if that's 1, that surely does look like it's at 2. This here was 3, and that looks pretty close to 7 there, So again, too, my diagram here means that I'm pretty confident in an exam situation that that is the center of that circle, 2, 7. So now that I have the center of the circle, what's the other thing that I need to get the equation of it? I need the radius. So all I do is I get the distance from the center to one of the points on the circle. Now I can either use this minus 2, 4, I can use this 5, 3. Now I'll use the 5, 3 because it's got nicer numbers in it. So all you do here is you go 5, 3, which is a point on our circle with our 2, 7. And we're going to use the distance formula, which will work out as our radius between 2 points. So you know our x2 minus x1 squared plus our y2 minus y1 squared. And we'll label up those points x1, y1, x2, y2. We sub them in. So I'll sub them in, pause the video and come back. Okay, so that was a nice result. They worked out as 5 when they got subbed in. So that's a nice feeling, because if it's a nice number like that, there's a good chance it's correct. So that was a distance of 5 units there from the center out to here. And that looks about 5. See the length of the green line? See the green line I'm shading in here? And this is also a length of 5 from 0 on the origin out to 5. So they look pretty equal in length. So I'm pretty happy this is correct. So I found the radius there to be 5. So then the equation of the circle, my final answer, is x minus, what's that? Oh, that 7 looks a bit stray there, but that's a mark on the y-axis. So the center is 2, 7. So then that's x minus 2, because this is your h and k, plus y minus 7 squared, and then equals r squared. Or is 5, c squared, that you get 25. And you'd leave it like that, you wouldn't multiply it out. Okay, so just to recap then on how this question went down, your flashcard note here on this scenario, right? I'll clear this away here so that we have can make a flashcard on what happened in this question, the scenario. What you had was a circle like this. There was some line here, and you had its equation. Let's get a color, right? I'll make up a completely new line here. So we have it. So it's 2x minus y plus 10 equals 0. And you had a point here which you knew. Let's call the point 5, 7, right? Okay, so what you can do here, and this is where this will be your flashcard. You can make this purple line here that goes through your center. And the way you do it, you can put it into your flashcard. You get the slope of this line, which might be something like it'll work out as 2. And that'll make the slope of this line minus a half. And sure, you'll know in your head then that once you have the slope of this line, you have a point that goes through, you can make the purple line. And you can also have on your flashcard how important it is to be making these lines that go through the center, because it sets up the simultaneous equation later to find the center. Okay, we love lines that go through the center of the circle. That's literally a bullet point for your cards. You're always looking for these lines that go through the center circle, because once you get 2 of them, you can use a simultaneous equation then to get the center. Okay, good flashcard stuff. Okay, on to the next example. The next example is a nice one here, where we have a line that actually goes through the center. They give us that for free, you know, and you'll see an example of that here. I'll go through it. So again, they're giving us a diagram there, but I'll build it up. Find the equation of a circle whose center is on this line. So they've given us a line that crashes right through the center, and we're also given 2 other points on the circle. So let's we could probably steal their diagram there. Yeah, there's nothing wrong with that, because we would basically be just sketching something very similar. So let me rub out the rest of their workings there. We won't need this part. So yeah, if we took a minute or 2 there, we would have sketched something like this. And they've kind of helped us with the part that I wanted to build up there. So I don't want this here for the minute. Okay, we'll get rid of that. Right, so what do I want to focus on here, guys? So the slope of this line here is minus what's in front of the x divided by what's in front of the y. So it had a slope of 3. So you can see the line that goes through the center of the circle, it's quite aggressive. It goes way up there like that. And then they graphed in 1, 1 and 2 minus 1 like that there. So this is quite a typical exam scenario where they're going to give you one of the lines that goes through the center of the circle, right? And so then that just means you really need another one of those lines that goes through the center of the circle, and then you can do your simultaneous equation. And as I said, one of your big things for make on your flashcard is this scenario. When you have 2 points on the circle, you can always create a perpendicular bisector with 2 points on a circle. So you can create that nice green line there that'll go through the center. And all we do is literally what I did in the previous example. We get the midpoint, we get the slope of AB, and then flip that slope, change the sign to get the slope of the green line. Okay, so let's do that here. So I'm going to pause the video here, and I'm going to get the midpoint of AB using the midpoint formula that we all know in our tables book: x1, x2 over 2, comma, y1 plus y2 over 2. So I'm going to get the midpoint there, that pink dot. Let me pause. Okay, so I worked that out there. It's a nice point. It's 3 over 2, comma 0. So now we have the midpoint, which is our green line, our perpendicular bisector we'll go through. So we just need the green line slope. So what we're going to do is we're going to get the slope of AB first of all, right, using the slope formula. So I'll do that here on the screen. So we're going to go x1, y1, x2, y2. So it's going to be y2 minus y1, which is 1, over x2, which is 2, minus x1, which is 1. And what's that working out as? We're getting a minus 2 on top and a 1 on the bottom. So the slope of that AB line, yeah, it does look quite aggressively downwards. So it has a slope of minus 2, which means the slope of the green line, when we flip that and change the sign, which is the actual slope we want, the slope of this guy here is a plus a half, as we can see going up there. So now that we have the slope of the green line and we have a point that it goes through, 3 over 2 comma 0, we can create its equation using y minus y1 equals m times x minus x1. So I'm going to create the equation of the green line now. I'll pause the video. Okay, so I done that there. The equation of the green line is 2x minus 4y minus 3. Let's do one of our sanity checks. What's the slope of this line? Minus what's in front of the x divided by what's in front of the y. That's minus 2 over minus 4, which is a slope of a half, which is what we should be getting from up there. So that's good. Okay, so that's good. I'll rub that away. Now, so what do we have? Oh, I'll get rid of that. Actually bring that back is the correct word. So now that I have, it's good to update the diagram too if we can get this in. So rather than writing a half here now, you can rub that out. You can write that that line is minus 4y minus 3 equals 0. So that's a reminder to you now that you will get the center C if you perform simultaneous equations on this line, the green line and the black line. So let's do a simultaneous equation on that. I'm sure you can all solve simultaneous equations, so I'll pause and come back with the solution. Okay, so I solved that there and I got 5 over 2 and half. Okay, now my diagram here is not well drawn. They just done a very rough sketch of this in the book. They could have done a better job. So you can see that the A looks like it's slightly below this center point, and A has a Y value of 1 and this supposedly has a Y value of a half. So this diagram isn't actually graph paper um, quality, you know. Whereas the diagram I drew for you earlier on in the previous question was better. So you'd be a little bit worried about this in the exam, that when you see 1 there in the half, but the maths are pretty bang on, so that's just what it is. And so then now that we have the center, all we got to do is get the radius. So we might get the distance to a point on the circle here, 1, 1. The distance between 1, 1 and 5 over 2, comma a half, and that will be our radius here, using the distance between 2 points. It's very similar to how the last question ended, isn't it? Y2 minus y1 squared. Okay, and you label those points up there. So I'll get that radius here. I'll pause the video. Okay, so I typed that in there. So I got root 10 over 2 for the radius. So now that we have the center, which is 5 over 2, a half, we have the radius, we can write down the equation of the circle, which is x minus, this is your hk, minus 5 over 2 squared plus y minus a half squared equals 10. So you square this now, you get a full 10 on top and you get a 4 on the bottom. Okay, cool. Right, so we'll make a flashcard on this. What's the notes on this question? So let's clear that away. So what did we see in this question? So when you have a line that goes through the center of the circle, it's really, really happy days, okay? Because that saves half of your time, because you know we're going to use these other 2 points to go and make another one of these lines. So your bullet point here is if you have 2 points, your flashcard is if you have 2 points in a circle, you can make your usual perpendicular bisector, and it really is happy days when they go and give you a line like L, which is another line that goes through the center, because then you can go and do simultaneous equations to get C, and then you can just get the radius by getting the distance from your newly found center to one of the other points on the circle, and you're done. right? I know a lot of people like the GF and C methods as well. So I'm gonna let's highlight how you would use GF and C in this here. Um, how GF and C gets used when you have a point that goes through the center. So pay attention to this here. So when you're using GF and C, you're really starting from this point here. 2gx 2fy plus c equals 0. And what you'd usually do in the most extreme example is they'd give you 3 points on the circle and you'd sub the 3 points in for your x and y and get 3 equations with g, f, and c as I done in a previous example. Now we can do that here, but we'd only have 2 points to do that with, so we need a third piece of information, and that's this guy here. Now, when you're using this format here, what's the center of the circle? We always half what's in front of the x and change the sign, so that'll be minus g, half what's in front of the y, so half 2f, change the sign, you get minus f. So we should all know that the center of the circle is minus g minus f. So in our diagram, we'd mark this in as minus g minus f. Now, this is how this works. This would be for your flashcard if you're into the GF and C methods. If they give you a line that goes through the center of the circle, because it goes through the center of the circle of your circle is known as minus g minus f, you can put the center into the line because you can put points that are on the line into the line, okay? And so that's what we do. We go 3, and in for x we put minus g, showing the examiner all this, minus y, which is minus f. See how I'm subbing in minus f for y, minus 7 equals 0. Why could we do that? Well, because look, this line goes through the center. The center is known as minus g minus f. Because that point is on the line, you can put the point into the line. And that's valid stuff. And so here you get minus g plus f minus 7 equals 0. And that is one of your triple simultaneous equations. This is a nice one because it doesn't have a c in it, as you notice. It just has a g and f. Okay, so let's create the other two. I'll just do this for maybe this point here, and then I'll pause for the other one. So what we do is we put 2 minus 1 in for x and y, and you show it neatly for the examiner like this. 2 squared plus minus 1 squared plus 2g bracket 2 plus 2f bracket minus 1 plus c equals 0. You tidy that up, you'll get a 5 there, 4 plus 1. You get a 4g here. You get a minus 2f. And you get a plus c equals 0. And then I tidy this up. Yeah, so what you do maybe is bring the number over the other side, something like that. So you get 4g minus 2f plus c equals minus 5. There's one of the equations. Oh, well, that's the second one now. So we get, where do we get the other equation? We go and we put our 1, 1 into the circle up here. Now this should be straightforward enough. You put 1 in there, you get 1 plus 2g, putting 1 in for x, putting 1 in for y, plus c equals 0. So then what we're getting here is 2g plus 2f plus c equals minus 2. And there you go. It's algebra days now for us, isn't it? You have 3 equations, 3 unknowns. And so the way you'd work this out here is you'd definitely just cancel the c in these 2 equations. Here you might multiply the top one there by minus 1 and add it with the bottom one here. So then you'd get rid of the c's, and then you can do a 2-piece simultaneous equation. Yeah, so that is for the people who use GF and C. Your flashcard there will be when you have a line that goes through the center of the circle, you put minus g minus f into that line. Happy days. Right, I'll clear this away. I think there's one other thing the book tries to teach us here. Just about showing a line as a tangent in the part 3 there. The way you show a line as a tangent, I've done an example on this before, where you can just use their perpendicular distance formula and show that the distance from the point to the line, this distance, is equal to the radius. And that means that the line is a tangent if the perpendicular distance is the same as the radius here. Okay, hopefully that makes sense. But I done that in a previous video. I'll zoom back to the question that it was actually on, just so people can remind themselves. It was this one here, 16, so you can go back to the video where I looked at that, and I showed 2 ways to prove that CP is perpendicular, perpendicular to a circle. Or yeah, see, show that, basically show that this red line was a tangent, yeah, by showing it was perpendicular. So you can study that question there. from before. I think that covers us here. So what I'm going to do for the rest of the video now, so thank goodness all that's over. It's like 6 pages of stuff. 11.3 is a pretty serious exercise with all the questions that are here. So I think there's like something like, 20 questions in this. So I'm going to highlight the tricky ones that we get some good learning from, okay? So I'm going to pause the video here and I'm going to start bringing up some questions that we're going to do where we'll learn some stuff from and we can be building up our flashcards as we move along. Okay, so I'll pause this. Okay, a nice soft question here in question 3 to get us going. All of these questions that I'm doing, you can obviously pause the video, give them a go yourself before I go and do them with you. Okay, so what do we got here? So we're told that there's some line, investigate if it's a tangent of the circle. This is exactly what I was walking us through there a second ago. So we know the center of this circle is -2, because that's a +2, so you change the sign, because this is in the HK format. -2, 1. Because this is r squared, we know r is 4. All we got to do is show that the perpendicular distance between this point and this line, that distance, if we can show that that distance is equal to 4 as well, then this tangent is doing this with the circle. That line is a tangent. It's doing a tangent business because the distance from the center here, this distance here is also equal to the radius of the circle. They're both 4. Okay, so that's I drew a sketch of that before. Anyways, let's set this up. I won't do it all on the thing because it's straightforward enough stuff. So the way you get the perpendicular distance, you do this formula here: ax1 plus by1 plus c over root a squared plus b squared. Usually before we sub into this, it's nice to make a table. We'd say a is 3, b is -4. You can draw it properly. C is -12. X1, the point we want to get the distance to, is the center. That's -2. This is 1, and then the distance is the question mark. We're looking for the distance, so we're looking for D. Right, we're going to sub all this in here. This should be straightforward sub in. I can do this on the screen. This is 3 bracket -2 plus B, which is -4. Looks a bit messy. -4, but sure, you can follow my words anyways, times 1, which is y1, plus c. C is a plus, so that's a -12. Then over the square root of a squared plus b squared. When you see a and b are 3 and 4, that means they'll square to give 9 and 16. And you take the square root of 9 plus 16, that's root 25, so you get a 5 on the bottom. So be on the lookout for the 3 and the 4s, because they'll give a 5 when they're square rooted and squared. Hopefully that makes sense. So D then up here, what are we getting? We're getting a -6, -4, and then a -12. All that adds up to -20. So we have a modulus -20 over 5. Modulus -20 turns into a +20, and 20 over 5 is 4. So the distance is 4, and you would just say equals the radius, and you write 3 dots, therefore it's a tangent. Okay. Yeah, that's fine. That's fine. I think we're all good there. Everyone's happy. Right, I'll find another question. Okay, nice one here in 5. We're told there's some circle, and we're told it has this center, right? I'm not going to do all this. I'm just going to see, can you put these pieces together on what needs to be done here? You're given the center of the circle. That's really powerful information, because then all you're missing then is the radius. And then you're told the circle touches this line, so this line's allegedly a tangent to the circle, right? So how could you get the radius from that? They're just after giving you the center. They're after giving you this line here. So then all you do, and I'm not going to do it because it's so straightforward, you just get the perpendicular distance from your center to this, and that gives you your radius. Okay, all good. Right, I'll clear this away. I'll find another one. Yeah, 7 and 8 here are very important. They love emphasizing this, where you have circles that touch one of the axes or both of them. So we're just going to do 7 here. You can pause the video, give 7 a go if you want. So what they're saying is the circle has center 2 and 2, and it touches both axes. So that means its sketch looks something like this. Okay. So what's the distance between here and here? Has to be 2. What's the distance between here and here? Has to be 2. But sure, what's that? That's the radius. So then you have the radius from this, you know. So radius is 2. So then the equation of the circle is x minus 2 squared plus y minus 2 squared equals 4. Okay, easy stuff. Let's do 8. So I've already done questions like this before, but the book has given these again because they're so important, you know. We're told that this guy has a radius of 2 and it's all the way up here at 3. And we're told that this circle touches the y-axis. So let's do a sketch of this. So you can pause the video there if you haven't already and tell me what the radius of the circle is. It's going to be this distance here, 2. So it's going to be the distance from the x-axis out, as you can see there. Um, so then if you're asked for the lower tip point here, what would that point be? Well, it would be 2, comma 1. Because if this here is 2, comma 3, the radius was 2, and you drop down by 2 to there. But anyways, we're not looking for that point. So the radius was 2, and center was this. So then it's x minus 2 squared plus y minus 3 squared equals 4. Okay, clear the web. Find another one. Yeah, so we're not going to do this question, but this is a good one to practice. So this is the really long version that I showed you in the example, and the book is nice to kind of lead the students through this, where what you're going to do is you're going to create perpendicular bisectors through AB. I'll use a different color. Where you get the midpoint, you get the slope of AB, then flip it, get the sine, get the slope of the green line. Then what you go and you do the same with BC. You get BC's midpoint, you get BC slope, flip it, change the sign, get the slope, and then equation of the purple line. Use simultaneous equations, find where they intersect. Like this is bread and butter equation of a circle stuff. This is your nuts and bolts. And then you get the center from your simultaneous equations, and then say get the distance out to this point, 1, 2, and that's your radius. Okay, and there you go. So that's how you do that. And you were led through it there in 8:10, so we're not going to do this question. Okay, so let me find another one. Let me pause that. Yep, we'll just do 11 here because they're telling us to find the equation of the circle, and they want us to use this format here. So they don't want us to go and do the bisector version of the previous question. So what they want us to do is they want us to sub these in for x and y, and then create 3 equations with 3 unknowns, g, f, and c. This is going to be really easy because see, some of the points have zeros in them. So if you're given this in an exam, the g, f, and c method is a good way to go because of the zeros. So I'll very quickly put the 0, 0 in, and you'll see it's going to basically just throw us out the value of what do I do? Putting brackets on a plus. It's going to just throw us out the value of c to f times 0. I'm putting 0, 0 in for x and y, plus c equals 0. All of that goes to 0, so then c is 0. Okay, so that's one of them. So that makes the simultaneous equation so much easier now that you don't have to deal with c. So even when you're putting in like the 2, 0 now, because I'll be putting in you still want to show it for the examiner, you know. So 2 squared plus 0, so the examiner knows what you're putting in, you know. 2g times 2, even for yourself too. If you make a mistake, you want to be able to look back at your workings and see what went wrong. Now at this point here, the fact that I know c, I nearly wouldn't be writing it down here. I'd be putting that in as a 0 on my own workings, but just because this is a tutorial video, I'll leave it in there for the moment. 4g, that's gone, and this is a plus c. Now, because I can actually find g here, I might as well do it. So because this goes to 0, so then you bring the 4 over, so g is minus 1. And then you just sub in the last point here. And as we're doing this, you'd nearly put in the values, you know. So 3 squared plus minus 1 squared, putting in for y. Plus, we know g's value, so you as well put it in 2 bracket minus 1 for g. What are you putting in for x? You're putting 3 in. Plus 2f, which is what we're looking for, times the y. Y is minus 1. Yeah, plus the c, and you can show that for the examiner that you're putting 0 in there like that. Great, so what do we got here? We got a 9 plus 1, which is 10, and we have a minus 6 here, so that's a 4, and we got a minus 2f here, and there's a 0 there, so that means f is 2. And look at that, you got your g, f, and c from that, and then you just put them in here for your g, f, and c, and you get your equation of the circle. I better do that here, it'll take 2 seconds. So you get x squared plus y squared plus 2gx. G is minus 1, so that would be minus 2x when you put the minus 1 in there. F is 2, so then this will be a plus of 4y. And then the plus the c, which was 0. No need to write it. You can just say nothing's there and then the 0. So that's the equation of that circle. And what's the center of that circle? it'd be 1 minus 2, but we don't need that. We just needed the equation. Happy days. Okay, right, let's move on. Let's move on from that. Um, okay. Let me pick, yeah, so there, like 12 is a good thing. You can do 12 whichever way you want. You can do it this bisector way, or you can use the GF and C. I probably do this the GF and C way because you see one of the points has a 0, 0 in it, you know, and I know that basically tells me from what I learned there before that C will work out as 0. But again, I wouldn't remember that off by heart. I would just on the day put 0, 0 in and notice C becomes 0, that kind of way. Yeah, we're going to do 13 now. I like 13. This is one we done in the example, so we're going to drive this home. So you can pause the video, give 13 a go if you want. I'll just go through it here because, as I said, it's really important stuff. So when I read this, right, I'm told usual business, a circle passes through 2 points, right? So when I know that when a circle passes through 2 points, I'll remember from my flashcard, I can always create a perpendicular bisector, which we love when we're doing a circle, okay? So you get 2 points like that on a circle. You can always find the midpoint of the 2 points like that, and then you can always get the slope of the two from the 2 to the purple, flip it, change the sign, get the slope of the pink line, and that pink line is called a perpendicular bisector, and they go through the circle. So when I read this question, my alarm bells are going off as I know I can do that. And then I'm really happy then to read on here further, and it tells me the center of the circle is on this line here. So they've only gone and given me another line that goes through the center. So that's basically the question solved in my head because I'm kind of prepared from the flashcards. You know, I know what to expect. They're gone and haven't given me another line that goes through the center like that one there. X plus 2y minus 6 equals 0. And so then I know I can use simultaneous equations with my pink and brown line and get the center and then get the distance from there to one of my other points here. But this one's minus 3, and then this one was 3, 5. Okay, so that's using the bisector method. They didn't want us to do that this way. They wanted us to use the GF and C method, but they'll never in an exam force you to use one method or the other. You know, you'll have the option to use whichever one you want. They don't usually force it at all like that. So how would you use the GF and C here? Well, you can just put, I'm not going to do this now because I've already done this loads of times. I just done it there before. You put the 2 points in here and you get 2 equations with GF and C in it. I'm just going to show you how you use the line here. I already talked about it. So you can pause the video if you haven't already. If you don't remember it from before, have a go at it. So we know the center of the circle, if we're doing it the GF and C method, is minus G minus F. That goes through the line we were given for free. Remember this nice free line? So because minus G minus F is on the brown line, we can just sub them in. We can go minus G in for X plus 2 bracket minus F minus 6 equals 0. Then you get minus G minus 2F minus 6 equals 0. Multiply everything by minus 1. And then we usually bring the numbers over the other side. So there's an equation. And where will that's one of our 3 equations for GF and C. The other 2 will come from putting the points in there into this down here. Put 3 in for X, 5 in for Y, and then you get something with GF and C in it. Minus 1, minus 3, put minus 1 in for X, put 3 in for Y, and then you get something else with GF and C. And away you go on your simultaneous equation. Okay, alright, pause that. Hopefully it's all making sense now for everyone who's kind of stayed with the videos. You're starting to see things click, hopefully. Let me find some other questions. Okay, 14 is good. There's a good lesson in 14. So what we like about this, you might make a little flashcard of this when it's done. They're telling us it's a really powerful piece of information here, right? The center of the circle is on the x-axis, right? That's super valuable information because that tells us, at the end of the day, when you're solving for the circle, we said there's always 2 unknowns. There's the center and the radius, but the center and the radius, right, are really like 3 unknowns. You see, the center always has 2 pieces of information. It's either HK or it's the G minus F, however you like to talk about it, you know. So a circle has 2 unknowns, really. It's the center and the radius. But from when you're solving for these unknowns, it's really 3 unknowns because the center is worth 2. So that's a nice flashcard there for anyone who doesn't know it. So we're putting together all our flashcards. So this is great. They're after telling us that the center of the circle is on the x-axis. So let's draw a diagram of that. Let's try and put that piece of information together. Let's draw a random circle with center at that pink point, because that's a point on the x-axis. Right, what does that tell us? Pause the video there and tell us what that tells us about HK and R. Okay, pause the video, have a think. Okay, and hopefully you realized that that means the Y value is 0. So K here is equal to 0, or if you're in your minus G minus F businesses, that means that minus F is equal to 0. Okay, so what we can do then is we can update this pink point here. I better use the same color. So it's really minus G comma 0. So it's now no longer a case of we're looking for G, F, and C. We're really just looking for G and C, you know. And look what they do. They went and they only gone and given us two other points. So what we're going to do with those 2 points is put them in up here. Obviously knowing, remembering that, you know, F is 0, because if minus F is 0, F is also 0. So I'll just put one in here, show you how I would do it. Because the G, F, and C method is nice when you have points like this, you know. You're given a free thing like that. So we got 4 squared here. I'm putting this in here. I'll put this one in first into the equation. 4 squared plus y squared plus 2g times x. I wish I didn't use purple because I use purple for my axes. Now this is it. So I'm not going to go 2fy here. I'm just going to write a big 0 down there, right? What you could do if you want to be really good for yourself and for the examiner, actually sub in your value for f and still sub in the value for y that you're putting in, which is the 5, you know. And then you got the plus c, and then you got the equal 0. Let's see, can I somehow move this away over here? Ah, there you go. Okay, so yeah, just like that. And then we tidy it up here. What are we getting? We're getting, what did I do? I done 5 squared there in my head, that's fine. That's 41 there, 16 plus 5 squared, 41, plus an 8g, that's gone, and then plus c. So things are looking good there. We bring the number over the other side, 8g plus c equals minus 41. Always circle that up for yourself and for the examiner. And then let's go and put the other point in here. I'll do that quickly with the video pause so you know. But yeah, you can see it here when it's unpaused. Okay, so I subbed that point minus 2, 3 into the equation there, up there, so you can see it quite clearly how I'm putting 2 in for minus 2 in for x and 3 in for y. And so when you tidy all that up there, you'll get the other equation, which is, what's that? That's 4 plus 9, that's 13, minus 4g. That number is gone, and that's a plus c. This is a really easy simultaneous equation now because it's minus 4g plus c equals minus 13. And then you solve for your G and C by using simultaneous equations on those guys. And you're done. Once you get your G and your C, you already have your F, and then you sub in there to finish the question to get the equation of a circle. Okay, cool. Hopefully everyone's happy with that. Yeah. I think everyone's good with that. So you'd use the G, F, and C method there. Do I want to make a comment on this, on how you'd use the other method with the bisectors? I could do. Right, I could do, just to show people what will go down here. So let me clear that away. I'm sure everyone's good with that, because we want everyone to be set up if you're using both methods, you know. But the ideal scenario you'd be as a student is to be able to use both methods. You know, you're not just stuck with using one type of method here. So usually if you don't like the G, F, and C method, you should be calling your center of your circle HK and R. Okay, HK, and your radius is R. So we know here that K was 0, right? Because you're on the x-axis, so you gotta put that in there, that K is 0, right? Now, if you're the person who likes the bisectors method, you've just been given 2 points here, haven't you? So what you're going to do is you're going to get the midpoint of them 2 points, and then you're going to get the slope of them, flip the slope, change the sign, get the slope of the perpendicular bisector that goes through the center. Let me do a quick dot of that there, you know, something like that there. That's pink. 4 or 5 there, minus 2, 3. So that's maybe something like here, we'll say. So what you're going to do is you're going to get the slope of these here, get the midpoint, and then go through the center like that, and you get the equation of this line here. Right, so I'm going to do that. I'm going to pause the video. I'm sure everybody at this stage, the amount of times I've done it, you create a perpendicular bisector that goes through this. So I'm going to pause the video and just do it all, okay? Okay, so we're back. So if you were the student who likes the perpendicular bisectors, you'd have come across this question here, this solution here for the perpendicular bisector, 3x plus y minus 7, and that's the perpendicular bisector that goes between those 2 points. Now, you'd be hitting a bit of a snag now. You'd be like, oh, what do I do here from here? I don't know what to do. But you do. You've actually been given a ton of information here. Just think about this, right? You're told that the center of this circle is on the x-axis. You know that the center of the circle is HK, right? So you can actually put, because you've just created a perpendicular bisector here, right? In for x and y, you can put the center of the circle, which is HK. All right, I'll do that for a minute. So we're going to put the center of the circle, which is HK, because look, we just made that perpendicular bisector. I'll try to get another color. I'm drawing this in purple, am I? We've just created that perpendicular bisector. This diagram isn't drawn to scale or in the right position because I just done it quick, as we remember from before. So 3x plus 4y minus 7 is a perpendicular bisector of these 2 points. It goes through the center of the circle HK, which means you can put HK into the equation down there. So that'll be 3 bracket h plus k minus 7 equals 0. Now, but we know something here. We know k is 0, right? So let's put that information in. So 3h plus 0 minus 7 equals 0. Look at it. Look at this. You can find h. H is 7 over 3. So now you have the center of the circle by using your perpendicular bisector, because you were able to put 0, which was the y-coordinate of the point of the center, which you knew because it was on the x-axis, into the perpendicular bisector that you made, and you're able to find the x value of the center, which was this. So we update this. That's out there at 7 over 3, and that's comma 0. To finish out this, then we need the radius, don't we? You just get the distance from 7, 3 to another point on your circle here, the 4, 5 out here, and then you get your radius. Happy days. So you didn't have to use GF and C here, but that's a big thing for your flashcard. The people who like the perpendicular bisectors know that you're working really with HK and R, and then if you can only make one perpendicular bisector, but you know one of the values of the center, like say the x or the y value, you can just put that into one of your bisectors. Okay, like I done there. I knew the y value was 0, so I was able to put y in for 0 on my bisector because the center is on the bisector. Okay, great. Hopefully that makes sense for everyone. That was a really good question. Let me pause this, clear this away, and pause this, find up another one. Yeah, I think 15 is good here. It's good. You can pause the video if you want to have a go at it. What I like is, again, they're bringing in a touching the x-axis kind of business, and they give you this. So what can we say about the equation of the circle? We know its center is 2, 3. Half change the sign in front of the x, half change the sign in front of the y to get the center. We don't know k, and we don't know the radius, because the radius here is our g squared plus f squared minus c. So then radius would be equal to square root, because this is minus g minus f. Remember, we don't worry about the signs because we're squaring here. So we get 4 plus 9 minus c. C is k, so we go minus k here. So you see, we can't get the radius until we get k. But you get some marks off the examiner for just writing that down if you're really bogged down with a question like this. So we have to somehow use this information that the circle touches the x-axis. The way you do that is by drawing sketches of the circles, right? So let's draw a sketch. Now we can actually do a fairly decent sketch here because we know the center of the circle is 2, 3. So I can come over here, I can come over here 2, I can come up here 3, I can draw a big dot for the center of the circle. Always mark these in as 2, 3 as well. And then we're going to sketch a circle. Now we have no idea what the radius of the circle is here. We could be drawing anything. But if you read the question, we actually do. It's more like the third circle I drew because we're touching the x-axis. So that's not a million miles away from what's going on in this question. Now pause the video if you haven't already done this question and tell me what the radius of the circle is. So hopefully you realize that this is it here. That's the radius. And that's basically just whatever the guy's y value is. Okay, because if this point here is 2, 0, the radius there must have been 3. I think that's what they call t, is it? The point at which is touched, yeah, so the t there, t's coordinates is 2, 0, as you can see there. Write down the length of the radius, yeah, so the radius is 3. And then we can sub that in here to this here. So we go 3 equals root 13 minus k. What do we do to both sides? Square them up. 9 equals 13 minus k. So then bring the k over, bring the 9 over, we get k is 4. Great, and so that's the equation of the circle finished because you just put in the 4 then. Happy days, happy days. Okay, right. I thought that was a good question. Sketches, guys. You gotta be drawing sketches. Okay, let's find some other stuff. This is going pretty well. These are all really powerful questions, so I'll keep doing them with you. 16 here. You can pause this video, give it a go if you want to have a go at this question. So it says there's a circle in the first quadrant touches both x and y axis. Great. I don't even need to read the rest of the question. I know a ton of information now, and I'm going to update that into a diagram. And this is the same way you've got to be now. When you're told first quadrant, circle touches both the x and the y axis, you want to be drawing this kind of a thing straight away. And then you want to fill in this diagram with the important information of when you touch the x and the y axis. That means this height here, this is the center, that's r, out to here is r, so I've already had you made a flashcard for this. We can fill in the equation of the circle, watch this. We can go, it's x minus r squared equals plus, I'm putting in the hk here, y minus r squared equals r squared. So we're just missing one unknown, so they have to give us one piece of information to find r. Look at what they give us. Now they want this question solved another way, but we'll just do this way to show you how quick it is. The distance from the center of the circle to the origin is 3 root 2. Right, watch this. You can pause the video if you haven't already done this. You mark it in your diagram here that this here, this came up in an exam, good exam question, that blue line is 3 root 2. Now, look at this. Study the Pythagoras here. You have this triangle where this distance here is r, this distance here is r. You can sketch that triangle as a little side task for yourself where it's r, 3 root 2, and you can do your Pythagoras on this. You square that side, what's that going to become? 3 squared multiplied by 2, I'm getting a 9. Your calculator would look after that for you anyways. Yep, equals r squared plus r squared. So that's a 2r squared. 2r squared equals 18. R squared equals 9. Remember, from an algebra point of view, you need to always be going r is plus and minus 3, but we know this is the circle chapter, r's can't be negative, so r is 3. Good habit to always be in when you take square roots. So now I have the center, I know the radius, so there you go. And as I said, you're never going to be forced to kind of do something in an exam here, where you have to use the G and the F version of things. But yeah, what does this mean if you were working with this? It would mean that minus G is equal to R. It would mean that minus F is equal to R. And then your other equation is R equals G squared minus F or plus F squared minus C, And you can sub some of this in here. Look at the algebra. This is just for the people who like the triple algebra stuff. I thought this was definitely the way to do it, what I done there, So let's see here how you would do this. Because minus G is R squared, that means minus G is R, that means G squared is R squared, and that means F squared is also equal to R squared. So you can sub these in here, where you get R is equal to R squared plus R squared minus C. And so you get R is equal to square root 2R squared minus C. Okay. Yeah, you would do it that way. Yeah, and then yeah, you're going to get your or, guys. You get your or. You have to do the only way you solve this question is by working or out from the Pythagoras triangle here, and you get or is 3, right? And when you get or is 3, you sub it in here. 3 equals square root of 2 bracket 3 squared minus c, and you get your c from that, okay? And once you got your c, remember your or was 3 up here, so that means then that your minus g is equal 3, which means g is minus 3. Hopefully that makes sense, and then f works out as minus 3. Because you're putting 3 in there, equals minus f, multiply both sides by minus 1. And you get that. Yeah, hopefully that makes sense for everyone. Cool. So the G, F, and C worked there, and then just the basic H and K method worked as well too. Great, keep moving along. Every question's been so far pretty good, so let me pause, see if there's any other ones good worth doing. Yeah, sure, we're on a roll at the minute, so we might as well do the 17 here. You can pause, give it a go if you want, or I can talk us through it. So like with these circle questions, it's always so much easier when you're actually just like solving the questions, And we're just trying to talk through like the initial examples, teaching you the stuff first, putting the flashcards together. They're quite tough because there's so many pieces you have to get used to. Like the circle is really something you have to get used to from doing loads of different examples, and making flashcards and learning the techniques, the flavor of stuff that can come up, seeing all the different scenarios. Right, the line 3x plus 2y minus 12 is a tangent. They gave us the diagram here, that's fine. We're told it touches the circle at 4, 0, that's fine. The circle also contains a point down here. Great, so that you should know from this here, we can create this pink line by getting the slope of this line here, minus what's in front of the x divided by what's in front of the y, so that's minus 3 over 2, which means the slope of the pink line then is 2 over 3. We know the point it goes through, so we can create the equation of the pink line. Okay, everyone should be good with that. We can create the equation of a bisector through AB because they give us AB as coordinates. We get its point, and then we go and we do the bisector through that, and then we'll get simultaneous equations. Find that, get the distance from the center then out to B. We've already done that today. So easy, isn't it? Okay, right, I'll clear that away, see if there's anything else. Yeah, looking at 18, 19 here, I'm interested in 18. I don't know if that yellow box is needed for us here to do 18. So the question I actually want to do is 18 at the minute, not 19. So I'm going to just cover this up. But you can make a note of that yellow box there. We'll see if we actually need it, I don't need any hints. Okay, so let's have a look. A circle passes through these 2 points, right? So if we did use the G, F, and C method, that's pretty good. They're after giving us 2 points, right? So then we know we could make 2 of the equations anyways with G, F, and C in it. Now they give us this other information that the line x equals minus 1 is a tangent to the circle. So I've shown you before in Desmos what x equals a value lines look like. They are vertical lines, right? So if I draw an x and a y axis here, if a vertical line like this goes through a value of 5 out here, its equation is x equals 5. If a horizontal line goes through a value like 3 here, its equation is y equals 3. So they have just given us the equation of a vertical line that is a tangent to the circle. So let's update this information here. Ooh, I want to rub all that away, but it's sort of in there now. Right, so let's draw a sketch of this. Now, there's another little sneaky piece of information here that you'll notice. Look at this carefully. So what do you notice about the x values? They're on top of one another here. So watch this. The diagram of this, I want everyone to pause the video and give a go at drawing a diagram of this circle, and you want to notice something. Okay. Okay, this is really important stuff. If you have 7 out there, and one of them is 2, another one is up here at 10. So again, always when you're putting in dots like this, always label them up so you know who's who. 7, 10, 7, 2. Now, think about this, right? They are vertical points. So this is literally, I'd make a flashcard out of this, right? They are vertical points, right? They're on top of one another. We know that the circle, I shall draw in a circle here just so people can see it. I'll do a bit of a good job of this as well too. I'll put the minus 1 in now. Yeah, so that I can draw a nice relative diagram. So I'll put the minus 1 in maybe around here. And we know that there's a vertical tangent, a vertical line that goes through here. It's a tangent to the circle, so let me mark it in here. I didn't want that color, I want purple. Okay. So I need to draw a circle that touches that purple line, but then also goes through my 2 blue points. So not far off there. Will that work? It's a bit big, isn't it? Not bad, not bad. Okay, that'll do. So we're going to make a flashcard on this fact. When you have 2 vertical points above one another, as always with all 2 points on a circle, you can always get the midpoint of the 2 points, can't you? And then get the slope of the 2 points and then do a perpendicular bisector like that. And that orange line will always go through the center of the circle. Now, the interesting thing about this is because these are vertical points, right? The perpendicular bisector will be a horizontal line, okay? And so the equation of a horizontal line is going to be really straightforward. So we can just get the midpoint of this here just so you can see. it'll still keep the 7 value um, there, and then it'll be the midpoint of the 10 and the 2, so that's 6. So the perpendicular bisector between those 2 points, 7, 10 and 7, 2, is this horizontal line that goes through 7, 6. I know the equation of that line straight away. Because it's a horizontal line that goes through a y value of 6, its equation is y equals 6. Now that means the center of the circle here lies on the line y equals 6, which tells me its y value. Okay, hopefully people are okay with that. Um, you can slow that down, you can rewind that back in the video if that didn't make sense, okay? But yeah, so what else are we given then as well? We're told that the circle goes all the way out there. Oh, I'm after losing my circle. And it goes and touches -1. Okay, so what does that tell us? We know that this distance here, let me draw a diagram. So there's a lot going on in the diagram. Is there anything I can rub out? Let me pause here, see if there's any way I can tidy up this diagram. Okay, yeah, so I tidied things up a little bit. I just kind of put in a full horizontal line there in yellow, and then I also labeled up my tangent here, x minus 1. So I tidied up a little bit, but we need most of the information that's on it. So now the next thing, so we're looking for the center, and we're looking for the radius, but we know something about the center. It had a 6 on the y value. Now, the fact that we have these 2 points as well here vertically, it tells us something about the radius. So let's do a little bit of searching for the radius. That's the radius's length there, or. Okay. Now you can draw a pretty decent triangle of this here. Kind of throw back to our trigonometry stuff. Because this vertical distance here, what's this going to be? So that's 10. This is 6. Down to there is 2. So you can see that you can get a 4 in there. Okay. Like that. And then you could actually continue the triangle down like this here. Because then there's a 4 there as well. And then up to here is a radius. So you see how a good diagram can kind of build up these things here. And yeah, any comments on that there? No, I think that's built up everything I wanted it to there. Yeah. So let me pause this here, see if there's any way I can tidy that up. Yeah, there's not a whole lot else I'm going to do in terms of tidying that up. So I'm going to show you the slick way that you can do this here. So this is important. So what's the length of this black line? It's the same as those black lines over there. It's r, right? So what's this gap length here? This is 1. Because look, we're gone back to -1 there. This is the y-axis, so there's a length of 1 there. So then what's this distance here from the y-axis to the center of the circle? If all of that there is r, then you come back 1. I hope people can see that that distance up there is r minus 1. And what is that distance? That is the x-coordinate here, r minus 1. If that makes sense. So think about this. If the radius was 10, this gap was 1, then we've come out here 10 minus 1, so that'd be 9. Then this would be 9, 6. Hopefully that makes sense. That's a big thing here that you can write down, that the radius is related to the x-coordinate there. So let's just put together what we have from our circle. We know that r minus 1, 6, is the center, and we know that the radius is r, right? So I'm going to show a cool trick then for this. Right, so when you have information like that and there's really just one unknown missing, because if you knew r's value, you'd know the center and the radius, you can still write down the equation like this. So let's do this. So x, right, this will look messy for a second, right? Hopefully that people aren't getting too panicked by that. That's just what h is, plus y minus 6 squared equals r squared. Now look at this. You can sub a point that's already on the circle, such as this one here. Let me get a color I haven't used. I've used most of the colors. Let's say 7 as 10 is a big number, so let's go for 7, 2. 7, 2 is on the circle, right? We can put that into the equation of the circle here. So I'm going to put 7 in for x. 7 minus r minus 1 squared plus 2 minus 6 squared equals r squared. Have a study of that red line. What is it? It's one equation. one unknown, and you can find your or from this, okay? So this is a way to do this question using kind of a diagram bit here and H and K business and HK and or. You could also have used minus G, minus F and C. So let me finish this out here so you can see it. There's a squared there. Is there? No, there's no square there. No, there's no squared on that. So inside that bracket, you're going to get a minus or. That'll turn into a plus 1, so you get a plus 8 in here. Plus, this is a nice number here. This will just be a 16. That's equal to an r squared. You watching this? So then we square out this bracket, r squared, multiply them together, double it, minus 16r plus 64 plus 16 from there equals r squared. We're only going to get one value for r here because our r squareds cancel. If I can get another color. R squareds cancel, so you have minus 16r plus 80. Let me write that out. Minus 16r plus 80 equals 0. So then r equals, what's 80 divided by 16? 5. So r is 5. Okay, does that look reasonable from the diagram then? So then if r is 5, then the center of the circle here is 4. And that looks pretty to scale there because I drew a relatively good graph paper quality kind of sketch of this, and that center absolutely does look like 4 if this is 7 here, you know. And so that's a good sanity check on all of that. I hope that makes sense there. This was a tough question, but try it. What flashcard will we make from that there? It's that you can get, when two vertical points are like that, you can get information about the x or y value by drawing a horizontal line like this, or a vertical line. For example, if you had two, it's a messy diagram now, you know, to be going putting other stuff in. But if you had two horizontal points that were on the circle like this here, and say that was 2, 0, and then this was 6, 0, well then that means the center of the circle has to be 4 something on a y value. I'll call it k. It has to be 4k because these were two horizontal points. The perpendicular bisector must go up between them. And so that the equation of that line, that perpendicular bisector, will be x equals 4 because it goes between 2, 0 and 6, 4. So these horizontal points and these two vertical points like this, they make your life quite easy with the bisectors. So that's how I got the 6 for free in this question. Any other comments then? And then yeah, this thing with the diagram as well here, how I knew that the tangent touched out here. And so I was able to go whatever its distance was there, or, and then make an or minus 1 here. And once I had the r minus 1, then I knew what I could write in for h there. And then this was a big thing here for your flashcard, that you can still put in like r minus 1 in here, and then put one of the points in like I did there, 7, 2. So you can wind the video back if you forget that, and you can make your flashcard on that works, and you can get your or then, because you've put in for x and y, you know, you get your one equation, one unknown or. Okay, good question. Let me clear that away. The G, F, and C method would just be the same. It'd be very similar with the kind of part there with the or minus 1, you know. This obviously being called minus G, and then you'd be bringing the 1 into it then, and relating the or to the square root of G squared plus F squared minus C. Okay, there's too much going on there for me to go through the other method, but hopefully that makes sense. Okay, I said I would just add one other thing because I'd kind of built up a diagram here and it looked like it was going to go a triangle route. So I said I'd show this just for anyone else who spotted this as well. This is another way to do it rather than subbing it into the equation like I'd done before when I actually solved this question out the first time. We're going to focus on this triangle here, this red triangle. Okay, and we're going to just get this distance here down to here, and we're going to get that distance here, the lower part of the triangle between these 2 points here. Now, what do we know? The point to the right has an x value of 7. Look at it there with 7. But the point to the left has an or value as an x value of or minus 1, right? Now think about this. We're looking for the distance between these 2 points, so it might seem confusing at first. Now, if I scribbled this out and I said, oh, this was actually something like 3, well, then you would say the distance between them is 4. So what are you doing in your head? You're doing in your head is you're taking the value to the right away from the one on the left, okay? So that's how you got 4 there. You went 7 minus 3. Now instead of it being a 3, let's have it what it actually is. It's r minus 1. So this distance here is the value to the right minus the value just before it here, the r minus 1. And so if you do the tidying up on that, you'll see that that works out there as 8 minus r. So that distance on the bottom of this triangle here is 8 minus r. So if I resketch that triangle here, just for those who are interested in how it was going to become a trigonometry question, the bottom here is 8 minus r, the hypotenuse is r, and this distance here is 4, right? You can use Pythagoras on this. You get r squared equals 4 squared plus 8 minus r squared. So then you're getting r squared equals 16 plus 64, multiply them together, double it, minus 16r, square the last term. Look at the r squares cancel, and you get the same thing that we got before, which is 80 equals 16r, and so r equals 5. Okay, so that's a slightly different kind of, this is me using the diagram and using trigonometry to solve that. So hopefully that adds a bit of value to those who are following that last question there. This is another way of doing it, getting your radius as that, which then makes that point 0.46 and the radius 5. So you have the equation then. Okay, thanks. Yeah, so I think I've done loads here. Anyways, there's no need for the tractor one. It's a bit silly. Okay, so that covers us there. Big long video, of course it was, but that is 11.3 from the text and test book. It's a big chunky section, and hopefully you learned something from that if you've managed to stick with me going through it, and you've made some good flashcards and you've prepared yourself with a few good questions. So in the next video, I'll move on to 11.4. Thanks for listening.